to today's webinar from the Open Group, which is the fourth in a series of events that we've done with APG. Before I hand over today's presenters, Chris Armstrong, JD Baker, I'd just like to go over a few housekeeping issues to keep the event moving forward smoothly. We would encourage you to ask questions during this event. We will ask the questions at the end of the presentation. There are two ways to submit questions. You can either submit via the text chat facility, or probably more effectively is to use the text QA facility. Write a question in one of those text areas. I can ask you to address your questions to either all or all participants. Everyone gets to see the questions that are being submitted. And as I said, we will handle all the questions at the end of the presentation. This event is also being recorded, so if for any reason you have to leave early, or if you experience any local technical difficulties, then a full recording of this event will be available from tomorrow. And everyone that's registered for this event will get an email, will have an appropriate URL where you can access that recording. And all our webinar recordings are now available via the Open Group bookstore. So with that covered, Chris, Jeff, if you're ready, can I ask you to start your presentation?
Okay, thanks so much, Simon. Welcome, everybody. This is Chris Armstrong, President of APG. This is our fourth installment in the DoDAF presentation series, where we're going to talk about some advanced implementation methods and techniques for DoDAF 2. And joining us for this presentation is JD Baker, a Principal Systems Engineer at APG, who also is currently the co-chair of Analysis and Design Task Force at the OMG, oversees a lot of the modeling specifications at the OMG, has contributed significantly to the development of SIML, the Systems Modeling Language, UML, and UPDM, one of the topics for today's discussion, as well as sitting in the Model Interoperability Working Group. Next slide, please.
Okay, that was my fault. I'll do a better at that next time.
So, basically go through advanced methods and techniques for formal modeling and sharing DoDAF 2 architecture descriptions, and part of this is going to be focused quite a bit on the latest version of what's called the Unified Profile for DoDAF and MODAF from the Object Manager Group, UPDM 2.0, is how having some of those formal architecture descriptions in forms that are aligned with unified modeling language and the systems modeling language, how that can help drive out the realization of our target architectures. And we'll also talk a little bit about the state of industry with respect to tool interoperability. So just about APG, our mission is to provide proven and practical process guidance for aligning information technology and systems engineering capabilities with business strategy. And we are members of a number of industry standards organizations, including, again, the OMG, as we talked about briefly before. We're also members of the Architecture Forum at the Open Group and contribute significantly to the advancement of the TOGAF architecture framework, as well as Archimate, and also have a role in the Eclipse Foundation as a part of the Eclipse process framework project. Partners with a number of tool vendors, including IBM Rational, as well as Sparks Systems and their Enterprise Architect tool. I think with that, I'll probably hand it over to JD to take the majority of the rest of the presentation talking about UPDM. So please welcome JD Baker.
All right, Chris. So our first question is, what is OMG UPDM? I'd like to start by telling you what it's not. It is not another architecture framework. It is not a competitor for TOGAF or a competitor for DoDAF or MODAF or any of those other architecture frameworks. Does it have a methodology or process component? There is a short, very level process included in the DoDAF documentation, but it's not a part of UPM. As we will discover a little bit later, ADM is a perfectly reasonable way to pursue modeling with the unified file for DoDAF and MODAF. There are two specifications, and so UPD-1 addresses DoDAF 1.5 and MODAF 1.1 and 1.2. And those of you that are familiar with DoDAF, you know that there was a very revolutionary change that occurred in that document, in that architecture framework between 1.5 and 2.0. And to quantify it for you, in DoDAF 1.5 there were 26 products. In DoDAF 2.0 there are 52 models. So we've changed the focus, we've changed the granularity of things, and we've changed even the nomenclature. DoDAF 2.0 can be applied to, or I'm sorry, UPDM 2.0 can be applied to DoDAF 2.0, MODAF 1.2 and 1.3, and the NO architecture framework. And there are a number of these defense-related, or at least defense-initiated kinds of architecture frameworks that are currently in existence. The NATO architecture framework is in large part on MODAF, and so it was easy for UPM to incorporate support for that. The group that developed UPDM was composed of both tool vendors, well, all three, tool vendors, users, that is your typical suspects in the large government space like Lockheed Martin, BAE Systems, etc., as well as government domain experts, and so it has received support from all three of those groups as well. So the current state of UPDM is that it is a mandated standard within the State Department of Defense, and it has been implemented by at least 4 different tool vendors that I'm aware of. UPDM 2.0 is on track to become mandated, and indeed expanding its mandate throughout the U.S. government anyway. In terms of the intelligence community has voted to train the Department of Defense in that mandatory usage. So those that support the UPM include ATIO, IBM, No Magic, and Spark Systems. And as Chris has pointed out, PG is both an IBM and a Spark Systems partner. Objectives of UPDM, okay, originally defined to enhance the producibility of models. Different modeling notations and lots of different standards were being applied. Some of them were very tactically applied, and there was a challenge of traceability between those. In the early days, when I was around 1990 something or other, when I was first getting involved with this work, I went to a training event in which for days we did a number of models, and then on the 4th day, did manual translation into an executable colored Petri net model. And the first thing that occurred to me was there is a very real opportunity for error here, and we're trying to take something that somebody has supposedly spent a large amount of time developing and trying to create an executable model out of it. And so, in order to try and improve the effectiveness, in order to improve traceability between the various levels of models and the various kinds of models, etc., the UPDM initiative was kicked off. If we have something that is more producible and higher quality, but more effective, there is some inherent reuse capabilities here. And if we are focusing on UML tools, then there's the notion of interoperability. So there are a large number of people in the world who for starters, have some knowledge of UL modeling, and so there's opportunity for us to have communication among stakeholders with a standard language as well as tool interoperability. Although it was probably not, it was an emerging objective, there was a desire amongst the various tool vendors to specify two different levels of compliance, one for UML2, and optionally add the systems modeling language, SysML, to extend the capabilities of modeling within UPDM. Gives us the ability to do a lot of expressions, to do a lot of organizations. Our SysML, for example, includes the notion of viewpoints, views that are conformant to IEEE 1491, the ISO. I'll get this number wrong, but I saw it Hilliard on the list. 490, I believe, is the specification for that. The thing about UPDM is that it was developed by OMG, which is an international standards body, and truly did draw input from multiple governments and communities, including Sweden and Canada, and to both the U.S. and the UK Ministry of Defense. So abilities, we model architectures. Not a surprising thing for us to do, and those architectures are intended to support a range of very complex systems. So they include hardware, software, data, personnel, facilities, what the U.S. calls the .mil-PF array. So the intention was to be able to model things from a system of systems approach down to what many people in the open group call solution architectures, that is, program and project architectures, with increasingly detailed design and implementation kinds of artifacts. A key component of UPDM is the notion of the ability to model services, and as we'll see, technologies that were brought to bear to enable that, and to support not only the modeling just for modeling's sake, but to support modeling for analysis, model for specification, design, and verification of those systems. The notion of improving the ability to exchange architectural information. A number of UPDM was the need to be able to exchange information between modeling tools. So there's a challenge associated with this development cycle that I'll talk about briefly here. And this is that governments, in this case DoD, MOD, NATO, Australia, Canada, etc., they do a number of framework kinds of definitions that focuses on acquisition, etc. And independently, industry supports and produces OMG produces modeling standards and engineering standards. Using those engineering standards, we take the DoDAF. Tool vendors implement those standards in terms of the architecture frameworks. People that are using those standards then produce models. As things change, then we have to go through the cycle. So there's a main cycle within the government to produce the architecture framework. There's a change cycle within the industry then to adapt or extend the standards necessary to produce, what is required for those government things. And then another change cycle that necessary for the vendors to then implement that specification. So it's important that the vendors participate in the development of the standards in order to shorten that timeline. Two compliance levels specified in UPDM 2.0. Level 0 is UML only, and level 2 includes UML and SysML. In fact, level 0 does also include a component of SysML, the unified profile, the UML profile for modeling services officially, UMS, but we call it SOML. So that embraces the notion of creating the services that the objective of UPDM. There's the chain of compliance here on the right, where you can see that there are two different pieces, the DAF and the MODAF officially, and so the UK government specifies MODAF and creates a MODAF meta model. DAF support DoDAF meta model, and both of those are incorporated into the UPDM domain meta model. And UPDM meta model is informed by both of those primary frameworks. We use that model to generate a profile, and that's not an automated generation. That's standard work that creates that profile, and then that profile is implemented by commercial tools. The commercial tools choose to which compliance level they wish to work at, and the use of those modeling tools then create UPDM conformance models, which can then be exchanged, etc. Here's the way the profile is organized. So again, there's a separate set of packages for DoDAF, a separate packages for MODAF, and then as you can see, the set of packages for what we call core outnumbers this for either of the two the separate things. So there's a lot of overlap between DoDAF and MODAF, and in fact that's quite intentional by the two government entities. They are working to converge and working together rather closely. So and all of the pieces, in some cases, as we'll see, some of those pieces are very similar, and things that are different include just naming. Things get named differently within those two frameworks, just because that's what the languages require from us. The viewpoints that are supported, and there's all views viewpoint include things like the vision or the enterprise definition of what am I going to do with this architecture, what is this architecture intended to describe, and what the dictionary or the ontology that is a part of that drives this effort. A number of other reports, things like measurement. Measurement wasn't a part of the original DoDAF work, and has included now in the version stuff. And so we're talking about things like key performance indicators and measures of effectiveness. And there are the top right-hand corner here. There is this thing called our value types, and that has to do with example that is included with the specification, and for most of the tools as well. So, strategic view. Strategic view is a MODAF nomenclature. In DoDAF, they call it the capability view. So TV1 is the same as a CV1 in this case. That is, what are the capabilities that we need, and what are we trying to do with the system, etc. Moving down the stack, we get to an operational view. And as you can see, there are a number of those operational views. Call your attention to one that we'll see a little bit later in the presentation, and it's this thing called OV1D. Okay, where is it? There we go. OV1D, operational context, fit for purpose. Right? So this is a key element of the architecture framework, and therefore a key element of UPDM and how we use UPDM. The framework developers can't possibly know what kind of models are appropriate in every situation, and therefore they have come up with this notion of fit for purpose. That is that you create the models you need, the elements and the relationships that you need to best describe your architecture framework, and you do that using UPDM described and defined and specified elements, and so therefore I can exchange that information without having a picture that looks exactly like somebody else's picture. On down the stack, there are the notion of services. One of the differences between DoDAF 1.5 and DoDAF 2.0 is the notion of systems and services. In one dive, they are together. So many of the views are called system and service, or system or service. It's very, very rightly so. DoDAF 2.0 separates those so that there are system views and there are service views, and they're necessarily coagulated. There's acquisition view that gives you some project kind of, and we'll actually take a look at one of the ACD3s, and then we'll view what standards that are being applied here, and how do they apply to the various elements. See examples of some of these, but obviously in the 45 minutes to an hour that are that's a lot. We don't have the time to go through all of them. So I'll go through these rather quickly. There are a few notes in each one of these, so that when we publish the slides, there will be some information that that might be of interest to you. So what I want to point out here is that an OV1 is often and traditionally very graphic intensive. And that's because it's meant to convey a tremendous amount of information in as brief amount of time as possible, so that admirals and generals and with that ilk can visualize what's going on. So in case this is a graphic intensive model of our maritime rescue example, but these are actually model elements, and model elements with relationships. And elements and relationships can be used for alignment and traceability as the enterprise or the system model is being developed. And some difference between doing something Visio and doing something with a tool that implements UPDM. These are true model elements that can be referred to and linked to in many ways. So one describes a mission or a class of mission or a scenario. A mission is some functional goal that stakeholders have. And by definitions, those are the definitions coming from the meta models and the architecture frameworks. But in this case, those definitions map very well to this notion of fit for purpose. So we use an extension of a use case with a description of a user's goal. That's certainly aligned with the definition of mission. And so we have the missions, the relationships to each of those missions, and the stakeholders that are involved in those missions. So you won't find an OV1D specified in UPDM or DoDAF or MoDAF, but it's applicable here, and it is introduced its capability of the language, and therefore the underlying language of UML and SysML that allows us to do this. So here too, in case node is a MoDAF the MODAF nomenclature. DoDAF, these would be performers. Okay, so an OV2 depicts key players. In this example, it's a seller operation, and the interactions for information exchange that are necessary between various nodes or performers. OV5 is a description of operations that are typically conducted within or by different nodes. In this, a search operation. So the they are related all of the operations that are conducted by search node, and all those operations are opposed. And so there are four different operations here: send warning order, find victim, receive the signal, and monitor health that compose the operational activity of search. And C is very familiar to those that recognize UML sequence diagrams or UML sequence diagrams, the same as UML sequence diagrams. And V6C is an operational trace that's used to define some kind of time-based behavioral scenarios. and trace is between the various kinds of operational elements. So, understand sequence diagrams. You know that what gets generally put on a sequence diagram are instances of a node. And here I have this notion of node roles that correspond to the various nodes in some other part of our operational diagram, and then the sequence of messages that flow back and forth. Fractions can also be defined on OV2 or the OV5 diagrams. And we can relate the various kinds of operational views one to the other, into that we have appropriate activities. And so one of these relationships could be that operational activity we just saw in the slide. On the stack, we get to a system resource, an SV1. So SV1 defines the structure and the internal flows of the system architectures. It describes and demonstrates how they realize the logical architecture that's defining the operational views. So again, there's a traceability relationship that needs to exist. When I describe the operational view, I have to have definitions within the system views that support those operational views. The bases and the various kinds of interactions are defined at a level that is necessary for whatever level we're working at. So they can be very level like they are here, or decomposed into any level of detail that's necessary to support our modeling opportunities. An activity diagram, this is an SV4, and it defines the functions that are carried out by resources. So again, activities associated with the various swim lanes, a very appropriate way for us to do that, and then we can show the movement of data in terms of pins and parameters in an activity diagram to describe this, again, whatever level of detail is appropriate. Example of an ACV3. This is something that was definitely not in the earlier versions of DoDAF, and has been informed by the MODAF effort and embraced by now the DoDAF. And it gives you the means of specifying a project. So there's three projects, three SAR projects here. These could be separate projects. They could be evolutions or builds or whatever we wanted to call about those. And each of them has their associated milestones in terms what needs to be done, what needs to be complete, etc., for each of the project instances. So turn it over to Chris again. I talk a little bit about how all of these architecture frameworks and standard languages, etc., how they might work across an architectural stack. And so from enterprise architects down to software developers, or some developers, hardware developers. At the very highest level, I have some notion of DoDAF, UM, perhaps the federal and defense enterprise architectures, etc. As we move down the stack into the program architects, DoDAF and therefore UPDM are definitely applicable to somewhat solution architecting that goes on below the enterprise level. As we move down the stacks, things like SysML and SOA-ML, etc., come into play. And finally, if we've done our modeling work, well as we might, we can exercise the model-driven architecture from the object management group to do model transformations that allow us to work at a level of abstraction and generate code from those abstractions. And there are still things that our developer community is going to need to do.
Thanks very much, JD. If you could advance to the next slide. So just to put this a little bit into context with regards to TOGAF and its architecture development method. For those of you that perhaps weren't able to join us the week before regarding the presentation we did on how TOGAF's ADM can support the delivery of DoDAF 2 capabilities, we have a whole hour presentation that gets into the more gory details. But at a high level, the ADM, one of the signature components of TOGAF, provides a set of best practices for describing how to initially establish an enterprise architecture capability, create a vision of where an organization wants to go with respect to its business strategy and target architecture, describing those baseline and target architectures through the activities done in phases B, C, and D, looking at the opportunities for aligning with what's going on in our market and what we need to deliver to achieve our mission, as well as exploiting the investments we've already made. We've put together plans for architecture-based transformation in phases E and F, ultimately generating an architecture roadmap. And some of the DoDAF views that we were looking at, particularly some of the project views, phasing views, kind of give us a vision of that. In particular, then TOGAF says, well, once an idea what the roadmap is, what the standards are, how we're going to kind of get there, it's really where the big EA as an kind of the top-down enterprise architecture stops. But that's where what to call the little EA need to pick up, namely enterprise architecture that can't be used to drive actual solutions isn't going to be very useful or helpful. So TOGAF focuses on how that interaction happens in phase G, implementation governance. And I'll talk a little bit more about that in the upcoming slides. Next one. So what APG, one of the things that we've put together to help provide some clarity on this is what we call the ATPL Plus Governed Solutions Architecture plugin. This is an extension to our TOGAF certified product, the APG TOGAF Process Library. That is a description of TOGAF captured based on an industry standard modeling language called SPEM, the Systems and Software Process Engineering Model, another specification that both JD and I worked on at the Object Management Group, and then a implementation of that is what's called EF Composer from the Eclipse Process Framework. And so we provide a more prescriptive definition of phase G as it relates to TOGAF being more of a descriptive method. It tells you a lot about what to do, but really differs to end users on the details of how to do it. So we get into a little bit more details in the GSA plugin. And one of the things that it calls out is some specific key deliverables that are a part of those handoffs, namely solution delivery recommendations, a solution architecture contract and an architecture review report as it relates to performing ongoing activities through the solution delivery lifecycle of making sure that enterprise architecture and solution delivery have a good idea of how they're going to engage each other, what kind of deliverables are going to be exchanged, produced, the kind of activities that are going to be mutually and jointly performed, and then of course providing guidance to the systems and solution delivery projects on kind of they fit into the architecture landscape and the things that they're going to have to in order to be compliant and conforming with the overall architecture roadmap. And then, of course, along the way, provide kind of oversight for developing those solutions. And as this plugin, we've identified two specific roles that aren't called out particularly in TOGAF, but are often generally understood as being important roles to play, namely the role of a solution architect and an architecture review lead. So one of the things that, describing this in the EPF Composer platform allows us to render some pretty nice viewpoints of the process. And here's a high-level definition of what, at least from an APG perspective, we think a solution architect is, which really we feel is the liaison between enterprise architecture and systems and solution delivery. So again, this is a role, not necessarily a full-time job, but it's important to know kind of what side of the fence that you're on, whether you're representing EA solution delivery or somewhere in between, which is kind of where this role fits. So two primary responsibilities are to describe the architecture context of the solutions to those projects, as well as identifying which architectural assets the project should exploit and possibly need to build or refine as a part of their implementation. And there are, again, some additional activities that the solution architect participates in as it relates to overseeing and establishing the initial engagement, conducting reviews across the life cycle, and involvement in migration planning and roadmap. Slide, please. So in particular, one of the key deliverables out of Phase G again are these solution delivery recommendations, and it really is a composition of 4 different types of content, particularly solution architecture context views. You think of these as kind of architecture blueprints that have been narrowed to the context of the individual project and its solution. So I often think of it kind of as a you are here map that we might often see in a mall or something. It's basically saying, here's where you are, here's where everything else is. But one of the things it's also supposed to do is establish that scope to say, this is part of the sandbox. Here's the things that you're going to be interacting with, and then by implicit definition, then you're not expected to be touching these other aspects of the enterprise. And so we'd expect to see in a DoDAF MODAF space, a lot of these would be fit for purpose and tailored versions of the viewpoints that make up the complete meta model. Then, of course, there's going to be an identification of which architecture assets the projects are supposed to either produce, use, or refine, and these would include things like patterns, frameworks, components, and services. And we expect that the architecture descriptions of UPDM would be, again, a basis for some of that content, particularly possibly seen through some of the dictionary reviews in the AV2. We also are important to understand our architecture requirements as it relates to solution delivery and systems engineering projects are expected to realize and deliver upon specific requirements that are identified by the architecture roadmap. So those are ones that the solution delivery project needs to understand that may be outside of their requirements that are narrowly related to their solution. And of course, conformance requirements that have to do with standards and processes that reflect how they're going to keep aligned with the target, the current and target architecture. All right. Yes, one of the design points that required us to actually create the ATPL plus GSA plugin is we wanted to actually integrate the two different life cycles of enterprise architecture and solution delivery in particular. It shows the rational unified process, which is certainly a well-known and widely adopted framework for software development and software engineering. It's coincidentally, unified process happens to be described in the same tool. There's actually a commercial version of it called Rational Method Composer. That's an extension of EPF Composer. But the fidelity of that process description is very prescriptive. And so we found it difficult to integrate a descriptive method like TOGAF CDM with the prescriptive method like unified process. So that's why we needed to extend Phase G to come up with this DSA plugin, which provides a lot more fine-grained focus on what are the things and how do they kind of interoperate and relate to one another. So it identifies, again, the outputs of the TOGAF architecture development method that are relevant to solution delivery, and those are, again, aligned associated with specific tasks within the unified process. And we were able to demonstrate, as I think, a lot of people know from general knowledge, but it was great to be able to specify this in the model and the process description, that enterprise architecture assets affect pretty much a complete solution delivery lifecycle, from project management to requirements, architecture, design, testing, validation, verification, of course, the actual implementation and configuration management. So this provides the enterprise architecture guidance to that solution delivery projects need in order to learn how to operate within that EA landscape. It also provides us a view into TOGAF, at least a subset of content that's relevant to people using the unified process. Back to you, if I'm not mistaken, JD.
Yeah. If I phone off of mute, you probably hear me too. So, interoperability were things that I talked about as goals of UPDM. And historically, the UML modeling tools have relied upon XMI, and this led to pretty much some point-to-point solutions. At one point in time, several years ago, we were able to identify 9 different versions of XMI that were in use across the multiple vendors. And interestingly enough, I got involved in the object management group in January of 2002 because they advertised a connect-a-thon between different UML modeling tools. And so traveled to Disneyland, and it was appropriate that this meeting was held in Disneyland because it turned out that the connect-a-thon was a fantasy. And I kept going back to OMG meetings until they finally got it right, and they get right by creating a group now called the Model Interchange Working Group. This is supported by at least 6 different tool vendors and multiple users, communities that are interested in being able to exchange models. Tools have come to realize that this part, people are interested in being able to change their tool every year, and so this is not really a threat to them, but it's actually an advantage to them if they can interchange with other tools, because that means that people that are working in distributed teams that have multiple companies involved in that development can actually work in their own tools and exchange information without loss. And so the Model Interchange Working Group is working on creating test cases. We actually had a live demonstration not too long ago whereby the testers had out a set of diagrams. In this case, they were UML diagrams. Challenged each implement to model what was on that diagram, and then use the XMI, and that go left, if you will, and everybody handed their XMI to the guy on the left, and imported that, and reported then on what were your conformance to the UML specification. What could you what could you not implement that was on that diagram? What was the import and export capabilities? And we had a number of successful import-export situations. So the thing that people struggle with in creating is the net of diagram exchange. There's been a couple of attempts to specify this. I think we finally got it right at the OMG. There is a specification called the diagram definition spec, and we can now, as tools implement that spec, it will be possible to exchange not only the model, but the diagrams of those model elements. So MIWG kicked off over 4 years ago. There are 16 public test cases, and there are test cases in work. I'm working on some issues related to test case 17, which is SOML, and next week we will be reviewing the first of the UPM test cases. Interestingly, just to show the scope of UPDM, there are 16 test cases that cover UML and SysML, an additional test case for SOML, and then a projected 12 test cases for UPDM. So we were working on those as we speak, and the capability will is sooner rather than later. All of these things, all of the vendors that are participating in the IWG are identifying issues with their implementation, or we're identifying issues with the specifications. Where there's ambiguity, specifications are being refined, etc. And what the bottom line here is that between these test cases and the emergence of something what we're calling canonical XMI, that is, the XMI specification allows a number of different ways to legally do something, and canonical XMI says here's one way, and there's NIST is working on tools to produce this canonical XMI so things can be evaluated and tested one with no variance in the XMI implementations. So at the beginning of this presentation, we mentioned the full exchange standard. Original DoDAF 2.0, one volume of that was specification for an XML-based exchange standard called PES. Things have happened. Some of the funding has been withdrawn, has been shifted. There's some, and work on PES has stopped. PES didn't, I don't think that work stopped before PES was complete and operational. And just because of some of those difficulties, the PDM and OMG in particular, OMG and UPDM in particular have been granted a dispensation that says that if you can make XMI work, then we don't have to worry about PES. And so that effort, and that's one of the things that has driven tool vendors to that are interested in implementing UPDM be able to exchange information. There's some other work going on within the U.S. government creating an OWL RDF representation. Maybe part of the next release ODAF, which is 2.0.3. The current is 2.0.2. 2.3 is slowly being work. Some of the responsibility within the government has shifted for who's responsible for DoDAF, and some of the work has slowed down a little bit, but there is that possibility as well. A feature of the architecture frameworks. In June of the year, there was a meeting regarding what we're now calling, or what's being called, the unified and maybe universal, don't know, architecture framework. What is that DoDAF, the MODAF, the DINDAF, which is the Canadian government architecture framework, the new architecture framework, are merging to create a single architecture framework. There is ongoing work to create a plan of action, and a workshop scheduled for this September to be held at headquarters in Brussels, and that particular group is actively conversing with the Australians, and they may be a part of that as well. So this could be the UPM team has been invited to this meeting for 2 days of discussions, and the UPM team is actually going to meet 3 days following that to discuss the implications and the road forward. Something that you can count on, UPDM 1.x will not go away until somebody declares DoDAF 1.5 and MODAF 1.1. UPDM 2.x will continue to exist as long as there's a DoDAF 2.0. There will probably be a UPDM 3.0, although it probably won't have the acronym UPDM, so it will be more than of DoDAF and MODAF. There will be a new version, so you can expect an RFP and some other instruments to for proposals once we know what a UAF is. Being said, I thank you for your attention and your participation today. And should you need to contact either Chris or myself, there is our addresses should be on the screen at this point in time, and we are prepared to take your questions.
Well, thank you, JD, and thank you, Chris. That was a great in-depth presentation. And I said the fourth in the series, so thank you very much for that. So this is an opportunity now. If you have any questions, please do write them in either the text chat facility or the text QA facility. We have a couple or a few questions already up there, so I'll just read those out, and JD and Chris, perhaps you can decide how you'd like to answer them. I'll go to the first question. It's on chat, and this is from Ken Young. Now, this is quite a long question, so I'll read it out slowly. So Ken asks, it appears from the diagrams that UPDM 1 favours MODAF of the views offered, and 2, alignment with CADM rather than DM2, because of the data concepts sound more like CADM, e.g. node, opera activity, etc. Do you agree with these assertions? If so, this points out that UPDM and DM2 are still not aligned, and that we have to make choice to align with either UPDM or DM2, but not both. A lot of guys, but can you answer that?
JD, you take that one?
Oh, yeah, I was winding up as we were talking. Anyway, my response to that assertion is no, I do not agree. All right. So there are a couple of things to explain. First of all, this was 45 minutes of presentation, and we chose specifically to include examples that covered both DoDAF and MODAF. And so what we find in the tools, right, is the ability to select either DoDAF or MODAF. And so if you look at the package structure, you find that there's that core set of packages that are always the same. And if you select DoDAF, you get MODAF nomenclature for and if you select MODAF, then you get MODAF nomenclature. As I pointed out, the things that show up in the example as nodes, if I was using DoDAF, would show up as performers. I believe, and all of the reviewers of UPDM that I'm aware of believe that we have achieved alignment with the D2, and so there's not choice to make between aligning with UPM, or I would say not rather than aligning with, but now using UPDM to produce two compliant architectures.
Okay, Dee, I hope that answers your question, Kendall. This question is from Alan Salzman. Are performance metrics estimated or actual presented for legacy versus target architecture, or perhaps an ROI?
Well, I'm not sure I understand the question. Okay, and so UPM provides the capability of modeling measures. Okay, but does not as part of the specification under how those measures might be applied or used, or whether as is and 2B kinds of architecture descriptions, or tied to an analysis of alternatives, etc. Where it's your choice as to how the measures are used within the model.
And just to add to that, I believe in the example of UPD artifacts that we've been taking a look at, that people can find in the latest version of the specification in Annex D, there's a description of how for example, the STV1 or CV1 has measures associated with different parts of the architecture as it transitions through the life cycle of the enterprise. So, obviously, the ability to do measures is a primitive capability within UPDM, and it allows those to be tagged to virtually any element, if I'm not mistaken, JD.
Yeah.
Thanks very much. And Alan, if you'd like to clarify the question a little more, if you'd like a little more answer, then please do so on the chat or QA. Next question is from Rich Hillard. Has UPDM conformance checked? He says, is it inspection, test suite, or self-declaration by vendor?
There is no external. In other words, OMG is not in the business of providing conformance tests, and so there won't be one available from the OMG. And so this is, for the most part, that self-declaration by vendor that will produce that conformance. Now, the other thing that we're working on, though, as a part of the interchange capability, is the fact that if you can interchange all of the various things that we will be testing. So the first is our tests around the capability view, and so sorry, I glanced up at the chat window. I shouldn't have done that. But the interoperability tests can then be applied to determine whether or not there is conformance there. Conformance to the specification was not their intent, but testing the capability to interoperate.
Okay, I'm just keeping an eye on the time because we're getting close to the hour. We have a secondary question here from Rich Hillard. He's asking, is Unified Arch Framework likely to be closed, i.e. fixed meta model, or open meta model, i.e. extensible meta model?
This, we're a month out from a very conceptual meeting at which none of us were present. Governments decided that they wanted to do this together. I don't know the answer to that question, and so somebody else knows more on that particular topic. I invite their knowledge, but let's have that meeting in September, and we have a roadmap and some other assessment of what that means. I'm afraid I can't answer the question about how the model's going to look.
Yeah, that's fine. So I'm looking at time. So we've hit the last at the end of the hour, but we've got a question here on QA. This is from Veer Munchandi, asking, what is the use of modelling actual projects using class diagrams? Would it be a maintenance nightmare to manage that kind of a model? Why would we just not use a project management tool in such a case?
Well, I could take maybe a stab at that. I mean, first of all, it really depends on the content of the class diagram. One of APG's best practices, and I think this is demonstrated by UPDM very nicely, is that calling something a class diagram it doesn't necessarily tell you about what the context of the content is. It drives more of the semantics. So, for example, UPDM exploits class diagrams at high levels of abstraction in, the operational views and the systems and services views. And those would all, again, under the hoods in the meta model be class diagrams. But, if you're talking about classic UML class diagrams, i.e., specifications of code modules, there is some of, I think, a reality check of, how do you keep that stuff synced with the implementation. But I think, we're at least from an architecture perspective, is not so much down into that detailed design, but the higher level architecture of the systems and the solutions. And I don't know if you have anything else to add to that, JD.
Well, it appears to me that the question may be around the acquisition views and the advisability of putting perhaps some of that project kinds of things into the model. And so I would say that in no way is UPDM intended to replace a project management tool or approach or what have you. It is a way to capture some of the high-level descriptions of what's going to be happening within a project so that, for example, we can do traceabilities between operational capabilities, operational views, and even system views, and say, okay, yes, I'll have all of the pieces within this particular architecture or solution model that will enable me to do those kinds of things without having to go look at Microsoft Project. And so it's a convenient way. It's the same reason that we capture requirements in a model, not because we want to make the modeling tool a requirements management tool, and best left to those tools that do that quite well. Is a way for us to be able to ensure that all of the requirements are connected to various architecture and solution pieces, and all of the solution pieces are based on some kind of requirement, and so you can trace those kinds of things.
And I could see, just thinking a little broadly, there's no reason that people need to consider OMG specifications limited to being exploited by first-class modeling tools. So there's no reason in my mind that a project management or a portfolio management tool could not be configured to export some of its content in UPDM XMI conformant approaches, so that content could be easily imported into a first-class modeling tool. Just exactly what you said, JD.
Right.
Okay, well, I think that's a good time to call it a day for this presentation. I'd like to thank both JD and Chris today for today's presentation, but also for the presentations you've given before the last couple of months. So thank you, guys. I'd like to thank everyone for participating today, and remind everyone that you do keep an eye on the Open Group's website for future webinars and future events. We do have a growing schedule of these kind of events, so we would love to see you at future webinars. So once again, guys, thank you very much, and I'll call it a day today. Thank you.
Thank you.
All right.